Leonardo da Vinci couldn't paint a gear that good. Sheesh! This 02 Dodge came in for some axle seal leaks. Let's see what's up. This is the front diff, and you can see it's really clean here, and it is, in fact, leaking. But differentials don't leak for no reason, so show them why, Michael. Oh no. We've also got very typical second-gen axle shaft seal leaks, and even the rear end's leaking. That's not good. This is the front differential carrier side-to-side play. Go for it, Michael. You can see that dial indicator moving. That's not good. We've got carrier bearing failure or lack of preload. And this is why we're tearing it down before we quote the job entirely, because that thing's got a nasty groove where that seal rides on that shaft, and an even worse one on this shaft. There's a low spot right here. It's really bad, and that means that this thing will not hold a seal. No real surprise here, but the front yoke is grooved pretty bad from the lip seal, and the rear yoke is also grooved pretty bad. So we're gonna need both yokes, 2 axle shafts in the front, and a bunch of other stuff. Magic Mike's gonna clean up this differential housing for us. She's looking pretty disgusting. Get those bearing races knocked out of there. Get this thing ready for an overhaul. These are those axle tube brushes Michael was cleaning the housing with. This one's spring material, and these are nylon bristle. We get these from goodway.com, and we just have a little piece of threaded rod that goes on here with a all-thread coupler to run in the drill. I had Michael clean these axle tubes because they had been leaking for so long that there was all kinds of stuff inside the tubes. It is not important that these be like super duper clean, because all you're trying to do is keep from getting dirt in the splines of the axle whenever you're putting the axle shaft into the housing, because there are seals right here, and there should never be any oil that gets past those seals. So it doesn't have to look brand new. There's still a fair bit of rust on that tube, but that is normal. This is not a rear axle housing where we've got to worry about hub bearings getting rust in them as the oil travels from the center section to the hub. I like using a little attachment like this to clean where these axle shaft seals ride in the housing. There's a lot of dust in there now because I just got done cleaning them, but gets that seal surface nice and clean. See how clean she actually looks. Oh no! So after lots of brake clean and a couple of blow jobs, let's see how she looks. Oh yeah, no more debris. That's what we're after. So we'll give it one last good blow and she'll be ready for assembly. This is his rear axle housing. You can see just how much rust is inside that assembly there. Not good. Let's see how Michael did on this housing. Looking pretty good so far. Tubes are nice and clean. We're going to go ahead and pull that differential vent out at the top of the housing there, because oftentimes there's a lot of rust in there, and whenever you pull that out, it'll fall down in the housing, which is not what we're after. So we're going to get that pulled out and cleaned out. On these front axle shafts, you can see they're both grooved pretty bad, which will not allow that to seal. Thankfully, Torque King 4x4 had the front shaft in a OEM spicer, and the long side shaft was actually not available anywhere for this 02, except for Yukon makes a center axle disconnect shaft delete, which works in place of this factory 02 truck that did not have it from the factory. Thanks to Yukon for manufacturing that, kind of saved our tail. We sourced all these parts from East Coast Gear Supply. We got a genuine Spicer 410 gear set for the front axle, master install kit from Yukon, a pair of yokes from Yukon for the front and rear. They're much nicer because they have the half moon lock for the U-joint there to keep it centered in the yoke. On the rear, he opted just to do the carrier bearings and roll the dice on the gears making some noise just due to cost. So we got a pair of Dana 80 carrier bearings and a super shim kit for a 10 1/4 Ford, but it works perfectly for the Dana 80. And then these are the hardware for the yokes. So I found something I'm not in love with. This axle shaft measures 20 thousandths smaller than this shaft. And what that causes, because these shafts are turning all the time as you're driving down the road, this seal rotates relatively easy on this shaft, and you put it over here and it's it's just not ideal. I'm not in love with that. So we're going to take this to a local machine shop and have them take 11 thousandths. I mean, it'll be 20 thousandths overall. But we're going to make this shaft the exact same size as this one so that we don't chance burning up a seal. Yukon manufactures this shaft with the intention of using their seals, and I'm not a huge fan of their conversion seals. It doesn't use a typical garter spring design like this seal does, and I'd rather use an OEM Spicer seal in a truck that came with Spicer stuff. So we're just gonna turn this shaft down a little bit, make sure that this thing lives a nice leak-free life. Huge shout out to our local machine shop, the Balf Brothers. Got this thing machined down for us here, and it's perfectly round. They said they ended up having to grind this down. They have obviously a machinist grinding tool of some sort, like a crankshaft grinder, because this is case hardened, and so the hardening of the shaft is just the outer section here. And I called my buddy Roy that owns PIM Racing, and he said on their shafts the hardening goes about 120 thousandths of an inch deep into the shaft, and we only took 11 thousandths off of this shaft, so we did not affect the strength of this axle shaft at all, but we did change the fact that it won't burn up that seal now. If you've already seen my Dana 80 gear video, then you're going to see a lot of repetitive stuff, but if you haven't seen any of our gear install videos, keep watching. You always want to make sure that your parts are correct. Just because the box says it is a 410 gear set doesn't mean that they packaged it correctly. You can see this is a Dana and it says 41-10. 41 refers to the amount of teeth on the ring gear, and 10 refers to the amount of teeth on the pinion gear. If you take 41 divided by 10, you get 410. So we are correct. The first thing we're going to do is take a flat file and file this ring gear mating surface to make sure there's no manufacturing defects in there that would keep the gear from sitting flush on the carrier. My file has quite a bit of stuff inside the grooves on it here on both sides. So they make a special tool for cleaning files, and you just run it with the grain like so, and it'll clean out all those grooves. Now she is clean. So we'll slide this sucker in the oven at 250 until she's ready. Then we got to come over here to Paul's toolbox, get his ladder out. I'm just kidding, I didn't actually need the ladder for this, and we need a temperature stick of 225. He opted not to change the limited slip or the gears on this axle and just roll the dice on it, not howling. The limited slip clutches are wore out, but it won't really affect the way the truck drives. It'll just act more like an open differential than a limited slip. So we're just going to put all this back together the way it was, and that's it. And there's nothing wrong with that. I would never do something that I feel would jeopardize the longevity of an axle. The ring gear having some rust pitting won't affect the gear. It's a Dana 80. He's not going to break it on a stock VP truck. The limited slip clutch is being wore out, also not a problem. And we're replacing the two bearings that were loose in the housing. The pinion bearings and races look perfect, so this will be just fine. These are the new yokes side by side, and you can see on the original ones the ears are really small, and so over time these little ears will wear out and the U-joint will be allowed to walk like this. It would take a lifetime to ever, I don't think that would ever wear out on this one, having that half moon worth of engagement there, and same on the front yoke. Check out how grooved that old one was. You can see that light where that seal was riding. That thing would never hold a seal. I will say on this Yukon yoke, if you need to use this on your axle, you'll have to get rid of this little dust shield. You can see the factory one didn't have that. This will work with certain style seals, but if yours has the style of seal where it has a flange that goes over the edge of the housing, this will not work. We got two genuine Spicer axle shaft seals from Denny's Driveshaft. This place has all kinds of stuff that's hard to find in a really organized website, so look them up if you ever need parts. Nothing makes me happier than that right there. We're able to source Timken everything on hub bearings, seals. We got AC Doco parking brake shoes, Timken hub assembly, Mopar axle shaft seals, and Spicer universal joints and pinion seal. Sometimes when you knock races out of the housing, you can create a little raised edge here, and that is not good because the race won't seat properly in the housing. So you need to sand that down lightly to where it's not a raised edge anymore. Sometimes to repair that problem, you can get in there with a big flat chisel or a punch and kind of just smash it back down because it's pretty malleable. I like to take this little grinder and get in there and just polish it down a little bit. Now keep in mind, you don't want to have to do this every dang time because you are taking material out of the housing, but it looks pretty now. Anyway. If you didn't know this, the carrier caps are line bored in the housing, so you wouldn't want to take this one and stick it over here because it might preload the bearing incorrectly. I've actually seen a customer where he had a bearing failure, and whenever I went to rebuild the differential, I had marked the caps like we did here, where we put 2 dots here and 2 dots there to keep the orientation correct. And whenever I bolted it in, it felt like it was really tight going in. And I pulled the carrier back out and I bolted the cap up, and I could see about a 1/16 of an inch gap here at the top. And I took the cap and I put it on the other side, and it lined up perfectly. So we knew that somebody had swapped those caps around. So do not be lazy. Make sure and mark the caps before you pull them off. I got to get this workbench looking a little better. I can't build differentials with dirt up here. So Michael was working on these hubs because we're waiting on brake rotors on these. So we're just going to clean everything off. That's mo better. Now we can work. You could eat off of this, but I wouldn't recommend it. Let's see if our gear's ready to eat yet. Oh yeah. When this melts when you touch it, means it's at the 225 degrees, which is what this says. So we're ready to install this on the carrier. We're going to do that same filing procedure on the carrier. You can see at some point there was a high spot here, and then somebody probably nicked it here when they were pulling the gears off. This thing's been into once before, and so you just want to make sure that somebody else's shoddy workmanship doesn't screw up your job. The reason we heat the gear is so that it will drop down on this carrier, because it's an interference fit. There's this little register here at the edge, and there's probably like a 2 or 3 thousandths interference fit, so you expand the ring gear so that it'll drop down easily and you can tighten your bolts without the risk of, if you don't heat the gear, you can risk the metal like shearing off part of this register, and so it'll get a metal burr that'll fall underneath the mating surface here, and then your gear won't be straight and it'll walk like this. All the new ring gear bolts come coated in oil so that they don't rust in the packaging, so make sure you brake clean them off real good before you apply your Loctite so that it will do its job properly. The same thing goes for the ring gear. It's coated in oil, so if you put these bolts into an oil-soaked hole, it will not do its job. So before we put it in the oven, we actually brake cleaned it off real good so it's nice and dry. I hope so. You're not bending now where you should be. See how it spins? That's what we want. Okay, all right. Okay. I feel like I'm Martha Stewart in her kitchen. So we're going to take this, since it just came out of the oven and we got it all finished up, we're going to set it off to the side and work on something else for a little while. We're ready to start assembling our axle shafts. This is an old one I'm going to use for demonstration purposes, but on these old stub shafts you can see there's a small amount of damage from where we pulled this U-joint out that commonly happens. So we're going to get in here with a round file and get rid of that burr so that our new U-joint doesn't get tore up on install. I do not have an excessive amount of load on those vice jaws, so it's not going to hurt the dang shaft. We got the round file here. We're just going to take that burr down, and we're going to flat file where the snap ring goes. And that'll help us greatly when it comes to installing those snap rings. See, no damage to the splines. It didn't get it perfect. But that's where Michael comes in. This machine has a little brush in the top, just like your traditional parts washer, and it runs fluid through it. So some of this stuff just needs a little bit extra scrubbing. We could leave it in there all day and it might get it clean, but I don't have all day either. This is how I prefer to install U-joints. I've got this little hand holder so Michael doesn't have to sit here and hold the shaft while I beat it.
You need to leave!
It's just something I made and it's adjustable. I used to stick the shaft through this hole on this one, so this used to be like an adapter for a drive shaft where, you know, it's a 4-inch drive shaft, and then this used to be for axle shafts, but this was built for a much shorter vise than we have now, so now this axle shaft adapter is just a spacer, and I don't ever use it. This thing doesn't ever try and fly out of here, so this is how we do U-joints. And I always hit U-joints in with a hammer. That is the best way to do it. If you try and put this in a press, and use any kind of press on here, these ears can bend in, because sometimes these U-joints are in there really hard, or even installing them, I've seen people bend these ears, and it doesn't take much. 10,000ths of an inch will bend this thing in to where you've got to take that joint back out and put a press in here and open it back up again. You don't want to go down that road. If you do get it bent and you hammer in the snap rings, well then your U-joint will be like super stiff. So hammering it in has never failed me. You just have to get good enough to where the U-joint needles don't fall out. That's the only problem I've ever had. These Spicer non-greasable joints are a factory joint, and they really last quite a long time. You're talking about upwards of 200,000 miles. So the one thing that's important on these is these caps have a predetermined amount of grease in them, and so you want to keep the cap in the same orientation that it was assembled at the factory. So I'm going to take a Sharpie and put a number 1 here and a 1 there and so on and so forth, so that these caps stay in the same orientation, so that you get the maximum life out of the joint. Just like that, they're labeled. It's very important when you're taking these caps off. There's a little plastic bushing in the very bottom that keeps this centered. It will sometimes stick to the end of the joint. You would not want to lose that, because then the joint could move side to side. We're going to drive this cap past flush, where it would normally it would sit flush, but we're going to drive it past flush. I try not to drive it to where the U-joint falls all the way through. We're going to hold the U-joint and turn it, and the reason we drove it past flush is now that U-joint is protruding through the shaft. We're going to check our numbers. That's number 2. We're going to grab the numero dos, and we're going to drop it down on there. And that's how I have had success with not dropping the needle bearings. You can see how high this snap ring groove is compared to where it normally sits. If you were to just drive it to where it normally sits, this U-joint wouldn't protrude through, and then you would have difficulty when you go to hit this in with those needle bearings falling out. Now we've got it seated, we're going to get a bigger hammer. Michael, hold that shaft so I don't screw up the video. Hold it here. And I drove it too far, so. Normally I wouldn't need Michael's help, but I don't want to ruin the video by having my arm in the way. And I cannot hit it with my left hand on a hammer. There, it snapped down. Now we're going to drive this back until that snap ring touches the shaft. Now we're going to rotate it over. And this snap ring fits in the groove really nicely. And now that U-joint is tight, I cannot turn it by hand, so I'm going to hit this, and now I can rotate it. That pretty much just allows those caps to come apart just a little bit, and now that's the way it's supposed to feel. Now the reason you want this really clean is because whenever you're putting it on, if there's dirt and stuff here, you'll transfer that onto the trunnion, and then it can cause the universal joint to fail. So that's why we have wire wheeled all this and blown it off with brake clean. Even though the shaft's rusty, it's not going to come off when we're installing this here. So orientation does not matter. It's not a drive shaft. It's not a high-speed shaft, so it's not going to cause a vibration because it's not balanced. Once again, normally I don't need Michael's help. Don't let it down. Just let me hammer it down. Kind of let it down a little bit. A little more. That's how I used to have to do it before I had that axle shaft holder. Michael, can you find that? Once again, it's tight. You can see how this shaft takes some effort to push it down. Shouldn't be that way. That's how it's supposed to be. That's one shaft assembled. Now we got to do the next one. Y'all ain't got to watch that though. Check out the wear marks from those clutches on that case half. It's kind of interesting because they're not straight. They kind of have some bend in them. That's why you wouldn't really just want to put clutches in here, because this surface and this surface are both wear surfaces, and as they wear down, it'll decrease the amount of preload on the clutch stack, and it won't allow it to work as well. Before we took this assembly apart, we did put indexing marks in here so that this case goes back the same way it came apart. We got red Loctite on all of our case bolts for this limited slip. The perks of having a large Wilton vise is that you can open this thing up large enough to be able to fit this Dana 80 carrier. I can actually grab it on the ring gear if I wanted to, but I don't need to. So now we can torque our carrier bolts. We don't want to go throwing away all of our old parts just yet. Since we are building Dana axles, we have to be able to remove the carrier bearings. So we need an old race to do so. I don't like using the new races for this because occasionally these rollers will put little indentions along the race, and so I prefer to use an old race for that. It's pretty rare, but it does happen. And since we're going to be using the super shims on this, we won't actually need to remove these more than once, so we don't need setup bearings for this Dana 80 carrier, because we found another solution that's much easier. See, from the factory, the shims go underneath that bearing, so anytime you want to adjust the backlash, you got to pull that bearing off, change these shims out, press them back down, put it back in the housing. Lame. We don't like doing that. If you were to try and use this puller without this race, it just pulls this cage and folds the cage over and then explodes the bearing, so you have to use that. Now you can see all that nastiness that was underneath that bearing. So we're going to get this thing brake cleaned off now that we're ready to start final assembly. Voila, now we're ready to press some bearings on. On this Dana 60, it's got the shims underneath the bearings just like the rear axle. But we're going to need to keep track of these for later, more or less. We don't want to have to start from scratch, so we're just going to throw these off to the side. It should be about even on the amount of shims per side. So we can throw away all the old bearings with the exception of the race, because we're going to need to pull these off to adjust our shim stack. Now we're going to pull the lower pinion bearing so we can get our factory shim out of there, or whatever shim's in there. So this bearing that we pulled off of here adjusts your pinion depth, and this shim here, which goes underneath this bearing, this is also an oil slinger, adjusts how far this pinion goes in and out of the housing, which therefore affects how it touches this other gear here. We should be able to compare our old bearing to our new bearing, and as long as these gears were set up properly at the factory, we will know exactly what pinion depth shim we need to put in here. Because you can actually, if you use a pinion depth tool, which we have one, but we don't ever use it anymore. It just takes a long time to set up. And a lot of these bigger differentials like Dana 80s and 10.5-inch Fords and 11.5s, they don't have the proper pucks and measuring equipment for those, so you're just back to doing it the way we've always done it. But with a pinion depth tool, you can actually set the pinion, you can measure the pinion depth shim without ever having even unboxed the ring and pinion. And so that tells you that the depth of the pinion essentially only relies on the housing and the bearing. It doesn't actually have to do a whole lot with the pattern. You just want to put it together and make sure it looks right, but you can get a ballpark measurement from your existing shim stack and your bearing. Since our old pinion bearing is not damaged in any way, we can go ahead and compare the old bearing versus the new one, and whatever difference we find here will be the difference in shim stack that we need to either add or remove from the pinion depth shim. So we have a set of steel parallels here, and we will, because this bearing cage protrudes past the race, we need to space this up properly. Okay, so we have two parallels here that are holding the outer race, and then we have one set up on top here on the bearing, and we're gonna rotate this until our dial indicator is right at 0. It just depends if I'm pushing down really hard on this bearing or not. So we're at 0 now on this old bearing. So now we should be able to very carefully take this and we'll see if we can't duplicate that. So we'll put this back on here. We're still at 0, so that's a nice repeatable measurement. Now we should be able to remove our old bearing and race assembly. These have both been cleaned with brake parts cleaner so that no oil is affecting our reading here. We're taking that measurement right in the center of that bearing. Ooh, doggy. Look at that. That bearing and race assembly is 25 thousandths taller than the old one. Even though it's the same bearing, same part number, and same everything, it's a different manufacturer. This is an NTN bearing, and that's a Timken. So we need to change our pinion depth by 25 thousandths shallower. Since our bearing is thicker, that's going to push it into the housing further. So we need to take our pinion depth shim and subtract 25 thousandths from it. We'll have to measure our pinion depth shim and then see what we can do about that. So just imagine if I hadn't set up this tool and taken that measurement, we would have already been 25 thousandths too deep just trying to reuse this factory pinion depth shim. And on a Dana axle, it is a royal pain to go ahead and install this thing, get your backlash within spec because you have to remove and install bearings and shims and stuff, just to find out you're too deep by 25 thousandths, which is a lot. And you're not just going to take out 25 thousandths of an inch. You'll be like, oh, I'm pretty dang close. You know, this is the factory shim. And so you're going to take out 5 or 10 or 15 or whatever. And so you might do 3 or 4 pinion depth adjustments before you even get remotely close to where you need to be. So this will get us very close to what we need to be. And we're already going to be close on our first try. We might be 2 or 3 thousandths off depending on what we see here, but the pattern will tell us. This fixture is called a dial comparator, and it is a perfectly flat machined piece of granite that has a dial indicator on it for measuring stuff just like this. So now we have to measure up all these shims. There are carrier bearing shims, there are pinion depth shims, there are pinion preload shims, and then for the rear we have the Dana 80 carrier bearing shims. So just tons of shims. But I tell you that who that's a job for is Michael. He gets to brake clean all these off, measure them individually, and then write on here for me what the thickness of each one of these shims are. And just going through this process, it's like a 30-minute job, but once it's done, and we don't have to pull out the calipers every time we want to make a 5/1000th of an inch adjustment to the pinion depth. We just already have it measured up. This is the differential specialty tools cart, and we have what they call setup bearings inside these cases. I've got Dana 44, 50, 60, 70, 10.5, and then miscellaneous. So we're going to need the Dana 60 kit. So this is a Dana 60 carrier bearing, setup bearing. So you can see I ground out the inside of it here so that it fits on. It's a slip fit. And so we can easily adjust our shim stack by just pulling this off, throwing some shims in there, taking them out, putting that back on, putting it in the housing, and then taking our pattern reading. And then whenever we're ready for final assembly, we'll press our new bearings on, put it back in the housing, and confirm that our preload is good and that our backlash is correct, and then then we're done at that point. But this saves a ton of time. I will not use a setup bearing on the Pinion. It's just my preference. I don't, especially on this one, because the Pinion shims actually go underneath the race of the Pinion instead of, like I stated earlier, they do not actually go underneath the bearing on this housing. You could put them there if you wanted to, but the shims that Yukon provide actually go underneath the race in this housing. So you don't need to be pulling the Pinion bearing a bunch of times, so we don't need to use a setup bearing on that. I will say if you wanted to use a carrier bearing on the Pinion, I do have them here. I just don't choose to use them because we've gotten to the point where most of the time, like if a differential's fighting us, you're talking about maybe 5 or 6 pinion depth adjustments. And to me, it's just not worth it. It doesn't save me that much time to not use the actual bearing that's going to be in the housing. That way, whenever I nail the pinion depth, I know it's done and I don't have to use a setup bearing, get my pattern right, pull it back out, measure the bearing on the comparator over there, and then should track shims again and then reinstall it and make sure that everything's perfect again. So I just prefer to just use the bearing that's going to be in the housing permanently as the one that I'm using during setup. This is my Diaper Harbor Freight 20-ton shop press that I've had for going on a decade now, and it still works as good as the day it was new. It's a little bowed on top because we have pressed some things that we shouldn't have in the past. But it works great for differential work because it's small and it's mobile. Like I just use a little dolly and I move it around, so I get it over here nice and close to the truck, so I'm not having to walk back and forth to a 100-ton press. And then another really nice thing that's a life changer is if you have a press, you need to buy one of these kits off Amazon that has sleeves, because you can throw away essentially almost every bearing race or spacer or anything you've kept over the years. I used to have a pile of random stuff. This is really nice because it's beautiful and organized, and you can close it up when you're done and just store it away. Doesn't take up a lot of room. It's really lightweight. You just pick the appropriate size spacer for your application, drop your bearing down, and press away. I've seen quite a few people mess this up. So we just push this bearing down on here, and you can see the actual carrier itself does not protrude past the bearing. The highest point is actually this bearing cage. If you put a spacer on here just to check it, and you try and rotate that cage and your spacer turns, that means that you have a problem, and you need to put, whenever you go to turn this over, because there's a bearing on the other side, we're going to turn this over, we need to put a spacer in here that will allow pressure to be only applied to either this inner bearing race or the carrier itself, and not actually on the outer cage. So if you just turn this thing over and put it on the plate, then you're going to crush this cage. And you might be okay with it. This one doesn't really protrude that far, but some of them really stick up there quite a ways, and you will destroy that bearing. Now we open up the old aluminum bearing race driver set and pick something that fits on that race, like I said. So you could turn this one over and push on the carrier, which is probably what we'll do because it centers up real nice. Or you can flip it around the other way and press on the inner race of that bearing. Now check it out. We got it turned over, got our spacer in there, and our bearing spins freely. So now we're ready to press the top one down. Look at what Michael did for us. We got all of our shims all measured up, except for we forgot the factory one because I didn't tell him to do it. So dial calipers on 0. It is a 75 thousandths inch thick shim. So, and if you remember, so this goes here underneath the pinion bearing. Our new bearing is 25 thousandths thicker, so 75 minus 25, we need 50 thousandths worth of pinion depth shim. Thankfully, our Yukon shim is not as thick as the factory one, so it leaves room for us to adjust our pinion depth. Pretty sure they knew that this was going to be a thing, so we got 31 thousandths on our pinion depth shim here, which is going to go under the bearing. 75 was the factory, minus 25 of the pinion bearing difference gives us 50. Then we subtract our 31. I'm doing this through the phone. So we need another 19 thousandths worth of pinion depth shim to add to the inside of the housing. So we're going to come over here to our nicely organized selection, and I'm going to just select 2 10s. 20 should be close enough to at least get started on this thing. Our 31 thousandths shim goes here, our bearing goes on, and then these two are going to get put here in the housing underneath the race. Now we got to come over here to the handy Yukon shim race driver set and find a driver that fits our race. We don't use these all that often, so they get kind of nasty looking, so I'll typically at least brake clean this off before we go driving a race with it, but sheesh, that's nice. There she is, all cleaned up. Don't want to forget your pinion depth shims. Race. Yeah, don't forget hearing protection. Whew. Same song for the smaller upper pinion bearing. Gotta find one that fits. There we are. I forgot to hit the record button like an idiot. But anyways, y'all don't want to see me pressing the bearing on, but we've selected our proper press, put it in here, a couple of spacers. I need to pick this bed plate up a little bit, but it is what it is. But we're nice and tight here. Nobody likes going in dry, so give her a little lube. I do my best to keep a kind of organized and clean work area. Both these roll carts, even though they look dirty, they are not. They're both really clean. I try and keep my tools on one and the differential parts on the other. And then this is my cheat sheet for myself because I have very terrible memory. So we just built us a cardboard Excel spreadsheet. Pinion depth, pattern, backlash, left shim, right shim, total shim, and bearing preload. It helps me keep track of where I'm at because the phone constantly rings around here, and I've got to stop what I'm doing in the middle of it, and I don't want to have to come back and guess, well, do I need to remove 3 thousandths or add 3 thousandths? Whenever you go to assemble the pinion in the truck, the pinion goes in, then this upper pinion bearing goes on, and this one goes down pretty easy, but normally it's really difficult to push this down. And what a lot of people do is they'll put the yoke on here. They'll have about 1.5 threads or 2 threads worth of pinion nut engagement here, and they'll try and suck this down, this bearing, down onto the pinion as far as it'll go with just the upper pinion nut. And what that'll do is that'll strip the threads off of this because that nut is not designed to do that. So what I came up with, because I got tired of seeing people do that, was I came up with this tool. It's custom. If you build one, do it at your own risk because this is not what this was designed for, but it's a air hammer bit welded to a piece of DOM tubing, and then you air hammer this upper pinion bearing on like that, and then it also works on the yokes as well. This one's a pretty small yoke, but it just barely fits, and then it'll air hammer that down like so. Like I said, normally this is an exception where this one's like really loose. This won't cause any problems though, but it does make it easier for assembly for me. Michael's gonna hold that pinion in there, and I'm gonna put some anti-seize on these threads just because we're gonna have to take this nut on and off quite a few times. This is normally where I would have to use the air hammer to air hammer this upper pinion bearing on, but that one slides on with ease. Then we're gonna slide this yoke on, and then now we can go ahead and put our washer and nut on. So we're just trying to put enough torque on this to where it's a feel thing for me, but you probably want like 30 inch-pounds of rotational drag. It's not going to hurt to put too much, and that feels good to me. This is not final assembly. This is just to get a pattern going. So these are the old carrier bearing shims, and they had 30s, 10, 10, and then 5 and 3. So since we're going to just do setup here, I'm going to remove 15 thousandths. But all this is just a guess at this point because we have setup bearings on here, and just as I showed you earlier, bearings don't have the same tolerances. If these are not the exact same bearing brand that came off of here, they could be another 25 thousandths too large. So we're just going to throw a random shim stack in here, try and put it in the housing and see where the backlash ends up, and the preload on the bearings, which is all done by feel for me. What we're after right now is to just barely have to hit this thing in with a rubber mallet to where there's no side-to-side play on it, and it actually is pushing on these carrier bearings a small amount. You see that ridge in that shim? That's because this thing is not perfectly flat. It's got a little radius to it at the bottom, and that's an engineering design for strength, but we need to make sure that we put this thing on with that raised lip pointing this way. Otherwise we'll be fighting it trying to crush this thing the other way. It'll act like a cone washer where it's not sitting flat. So we're going to just turn this the way that it was initially. I don't like that idea. That's why I really like when shims go on the outside of the bearing, because for setup bearings you're not going to be able to crush that down. And so we're going to get this thing close, and then whenever we put our final assembly bearing on here, I guarantee you it's going to crush those shims down because it's actually pressed on there, and our backlash will be wrong, but that's just part of it. That's not bad. You hear that? We got some backlash. On the caps, I like to do a little, I put a sideways one on here and a vertical one on this side, just for ease of installation. I don't have to look for the dots as I'm trying to assemble this thing. Just much easier to see that yellow paint. Daggum, I got lucky. Just for starters, we've got right at 8 thousandths backlash, and that is the amount of play that this gear moves forward and back. That's going to be too much because this is what they call a two-cut gear. So if we reference our handy-dandy Yukon pamphlet here, we go over to Dana 60, and a two-cut gear is going to... Oh no, they don't list it. Why? Because it's a factory Spicer gear, and I guess Yukon doesn't make a two-cut gear for a Dana 60. So now we got to go look at service information. Alright, they're showing a backlash spec of 5 to 8 thousandths. Since we're at our maximum 8 thousandths backlash on the gear, we're going to go ahead and paint a section and run it through and see what our pattern looks like. We prefer to use this gear marking compound. It's green in color, obviously, and then we use an art brush. It's pretty fine on the bristles. Otherwise you get streaks in the marking compound with the little cheap brushes that they send with the yellow paint. We're just going for a nice even coat on the gears on both sides. You can get your pattern two different ways. You can either put a wrench on the ring gear and run it through up and down, or you can put a drill on the pinion and rotate it that way while applying some load here with like a glove. Just make sure not to get your hands sucked in there. Ready? Yep. Okay. Ooh, that looks like shit. Yep. Okay. That looks like doo-doo. Big doo-doo. Oh my gosh. That's terrible. Well, all that fancy measuring was for nothing. That thing is way shallow. It's riding all the way out here on the edge of the tooth. That is not good, so we're gonna add more pinion depth shim, and that'll push that pattern deeper. What I'm looking at is how this pattern, the gray area is where the gears are touching, and that that gray area runs right off the edge of the tooth, which is a telltale sign that this gear is too shallow at the moment. It does it on this side as well. So the book says you are too far away. The way I like to remove these carriers is I take both the lower bolts out, I leave the caps on, and I just loosen the upper bolts so that if I go prying on this thing and it decides to come out of there, it's not going to fall on the ground. Now this one, since we're just doing setup, it's a little loose. It didn't have any side-to-side, like there's no side-to-side play in there, but whenever I go back together, I'll add a little bit more for this next go-around. Probably add like 5 thousandths. So these are the notes from my first setup. So we ran 51 thousandths on the pinion depth. It ended up being shallow at 8 thousandths of an inch of backlash. Our left shim on the carrier was 45, right was 43, total shim was 88, and the preload was loose. So now I know, so if I get interrupted now, I can come back to this in an hour or so and I'll know I need to add pinion depth because I was shallow. I need to add a little bit of shim because I was loose there. And if I was trying to adjust the backlash, I would choose where I wanted to put those shims, on the left or the right. And now we get to take the pinion back out of the housing. We got to take the nut off and air hammer this thing out of the housing. It'll probably fall out because of how loose those bearings were on there. And then we get to knock the race out of the housing and add probably 10 thousandths of an inch is what we're just going to go for because it's way off at the moment. Hey! That came out a little too easy. That normally doesn't happen, and so what you'll do is you'll air hammer this pinion out, and what'll happen is the vibrations from that air hammer will loosen this lower pinion shim, and that is not good. So anytime you take a pinion out with an air hammer, always repress that lower bearing to make sure that this shim is tight, because if you do not, this used to bite me in the butt because I didn't know that was happening, because most of your pinion shims are not an oil slinger like this, so you can't really visually tell that they're loose. So what would happen, I'd be making pinion depth adjustments, and I was like having real inconsistencies in, like, I would try and add 3 thousandths and then the pinion depth would be stupid deep or something like that. And what was happening is that pinion bearing was hopping off of the bottom of the pinion by like 10 thousandths of an inch, and when I would just snug this nut up here, it wasn't enough to pull that bearing back down there because it takes a lot of press to push that down. So I was having a hard time building differentials when I first started out, until somebody told me about that, and I'm super grateful for them having mentioned that. And some boomer will come in here and say, oh, I ain't never had that problem in 30 years. Well, I'm here to tell you, you've been doing it wrong for 30 years. Now we gotta hit this race back out. Now I really wanna try my best to not mess up that cast iron housing when I'm driving this race out, so I'm gonna be real careful on where I hit this. We also wanna try not to hit the shims either, so that we can reuse them, because if you hit them, it'll raise the edge and then they won't be worth anything. Father, help! Here's our shims. You can see I boogered them up, hitting them. You can see if we set this shim down on top of the bearing, or on top of the race, there's not a lot of room to get in here with a chisel and hit this bearing out, or hit this race out without catching those shims. So thankfully I keep a stockpile of these. We're gonna grab all 3 5s, the 10 and 1 6 for a total of 31. We had 20 in there, so now we'll have an extra 11 thousandths worth of pinion depth shim. Now we get to beat the race back in the housing, but I'm not going to make y'all watch that. The pinion is back in the housing and ready for us to drop the carrier in. But if you remember, I said I wanted to add 5 thousandths to our carrier preload shims. And it's an educated guess here because the pinion is now closer to the ring gear, so that's going to tighten up our backlash. So I'm probably going to add the 5 thousandths on this side to push the gears away from each other to try and open up that backlash, but it wouldn't surprise me if it opens it up too far. Well, we'll see. It's just precision guesswork. Now just imagine how much of a pain in the butt this would be if we didn't have setup bearings. You would literally have to use the puller to pull this off, select your shims, and then put it back in the press just to put it in the housing, find out that it's wrong. This is exactly why I really prefer building AAM axles, because they've got the side adjusters here so that you don't have to deal with shims on your carrier preload. Beautiful. There are some people that will actually defend building differentials without precision measuring tools like we have here, which is just ignorant, if you ask me. But hey, I don't have to warranty it, so you do you, boo. We're at 9 thousandths on our backlash, which is a thousandth out of spec. I'm gonna go ahead, we have a 3000 shim here. I'm gonna take that and put it over here, and that'll move the carrier over and tighten up that backlash. I went ahead and moved 5 thousandths on the carrier shim from the right to the left, and we are at our minimum spec of 5 thousandths on our backlash now. So we're gonna go ahead and run a pattern. Shit, Leonardo DiCaprio couldn't paint that good, son.
You're an idiot. It's supposed to be Leonardo da Vinci.
Oh shit! Shit, Leonardo da Vinci couldn't paint that good. Alright, this is our second pattern. We're looking a lot better. The drive side of the gear looks a lot better now. The coast side is still a little shallow for our light, or well, it is shallow. So we're going to go ahead and remove this and add another 5 thousandths to our pinion depth and try again. The coast side is still running right off the edge of the tooth. So we're going to go ahead and add another 10 thousandths to the pinion depth shim and see what it does. I'm not going to drag y'all through watching me change the pinion depth shim again, but since we're going to be adding 10 thousandths and our backlash was already at 5 thousandths, which was the bottom of the spec, I'm going to go ahead and take the 10 thousandth shim from this side and stick it over here to open up that backlash in preparation for that pinion being deeper towards the gear. We are getting closer. We're still shallow because the coast side is running off the edge of the gear, just like it always has been. And we're at 69 thousandths overall pinion depth shim. And the factory, if you remember, was 75 thousandths. So we're gonna just go for 75 and see what the heck happens. This is 44 thousandths pinion depth. Paul thinks we are too deep now, and I think we're maybe a little too shallow. So I'm gonna add 5 thousandths and see what it does. It'll obviously get much deeper if it is deep now. Here, Paul said the pattern was deep, and I said I thought it was shallow, and I ended up going my route, and it looks even deeper. So we're gonna go Paul's idea and pull some shim out. This is the pattern we're gonna send her home with. We're happy with it. Looks pretty good. And we did as much adjustment on this thing as we could. We ended up taking 8 pinion depth adjustments before we found one we were happy with. And we were at 38 and it was shallow, 42 and it was deep, and then so we split the difference at 40, and that's where we're at now. And that's the best pattern we've had, and we don't feel that it can get any better than what it's at currently, so we're going to continue on. Now that we have a pattern that we like, we're going to go ahead and pull the carrier and the pinion back out and get ready to put the crush sleeve in and tighten all that down. These are both Spicer gear sets, and can you see the difference between this one and this one? It's the height of this ridge here. So this is a crush sleeve style pinion, and this is a shim style, because this bearing goes down here on this machine surface, and it's going to ride somewhere about there. And these are the two different ways you adjust your pinion bearing preload. So on the one on the right, you would use a crush sleeve, but the one on the left, you can't get a crush sleeve in here because there's not enough room. So underneath that bearing, you've got these little shims that we've measured up, and we will have to adjust how many we have in here to set our pinion bearing preload. So the preload is adjusted by spacing these bearings further apart or closer together, and that changes the amount of rotational drag you have on these bearings, and they give us a spec that we need to hit. On a shim style differential, we will have to pull this out more than likely several times to get our shim stack correct, because it's just precision guesswork at the end of the day. Versus this one here on the right, you would assemble this in the housing. Obviously you'd have a bearing down here, and then you just drop this on the top, you put your yoke on, and you tighten the nut. It crushes this sleeve until you get the proper amount of rotational drag, and you are done. These are the ones I prefer to set up because it's one and done. You don't have to take it back apart. So in order to get a kind of guesstimate ballpark figure on what our pinion preload shims need to be, I used to just have to throw random amounts of shims in here. I'd throw 3 or 4 and put it in the housing, and it'd either be way loose or way tight, or occasionally I'd get really lucky and it'd be really close. Somebody on a Facebook page showed me this trick where you take a piece of solder, really thick stuff, you wrap it around the shank of the pinion, and then you put this in the housing, you tighten it down to where there's no preload on, or there's no slack in the bearings. Then you take it back apart. This will have been crushed, and it will give you a very close idea as to what your shim stack should be, because it's the distance between that bearing and that little flange there. So we've got our piece of solder that we cut. We're going to slip it down on there and then just kind of smush this together with our fingers here. It's hard to do one-handed. And then we can put this in the housing and see what it is. So we've just loosely assembled this thing in the housing. The nut is not tight. Pinion still moves in a bunch. We're just going to snug this up. And you see how the nut is tight, tight, but we still have bearing play. That's because of our solder that's about to be crushed by this impact. You just go until the bearings are nice and snug like that. Now you know that there's no more play in and out in the housing. Now we can take it back apart and measure our solder. Here you can see our pinion with our crushed solder. Occasionally, the solder will overhang the edge of the pinion, and so you'll have a thicker portion out towards the edge, and you do not want to measure that. You want to measure the thinnest crushed section, and that will give you your shim stack. But this one is nice and flat all the way across, and we are sitting at 67 thousandths of an inch. So now we need to find 67 thousandths, roughly, worth of shim to put on there to see if our pinion preload is going to be correct. I've got 69 thousandths worth of shim stack here.
Bombastic side eye.
That we will drop down on the pinion, reassemble it in the housing, and see what our pinion rotational drag is. You want to make sure there's still plenty of lube on the bearings, because that will affect the rotational drag. And for now, I'm just going to impact it down with my 3/8 impact. This is more of a feel thing. They do have a torque spec for this nut that we will follow in the steps going forward, but right now I just want to see if we're even remotely close, because if I torque this to 50 foot-pounds with my impact and it doesn't turn, or it goes in and out of the housing a bunch, then I know that I'm not even remotely close on my shim stack. So right there, that was like, this is feeling pretty good. Oh yeah, I like this. You can only crush those shims so much, so the fact that we're not actually torquing this is not a huge problem. If this was a Dana 80 where you get to torque it to 500 foot-pounds, that's a different story. But this little impact max power will be sufficient. I think we might be on the money. It feels almost perfect. If you're ever doing differential work, do not waste your money on this one. From Cornwell, it's like 350 bucks, and it sucks because the scale is so strange, especially for smaller differentials where your maximum torque reading on like a Dana 80 would be 45 inch-pounds or something. You want to make better use of that. This one only goes to 100 inch-pounds, and so it's a much smaller scale. And if you see here, it's zeroed. It's just the weight of the wrench is enough to offset that dial. But we are almost where we need to be. We're at like 16. So you could honestly leave it here, but we'll go ahead and pull another 1,000th out of it and see what it does. Here is 1,000th less on our pinion preload shims. Over our spec, we're at 35. And I'm gonna go eat lunch because I am dying. Let's see if third time's a charm. Nope. Well, maybe. It's so loud. Okay, we're just shy of 30, which is in spec. Now we're going to torque that nut and make sure that that reading doesn't change. So the factory service information doesn't actually give a torque spec on this nut because it's a crush sleeve style differential and they don't get torqued. But Strange lists the torque spec as 120. So I trust them guys. They know what they're doing. Give it a little extra beans on accident, but can't really over torque it. This way you always want to torque that pinion nut in order to check the preload, because that is too high now. We're well over our 30-inch max spec, and it's consistently over 30. So we need to pull it back apart. And I bet if we put our starting shim stack in here and actually torque that nut, that it will be the proper preload. So this is back at our factory, or the first pinion depth reading here, and we're well within spec when it's torqued, so we're good to go. So on our pinion bearing preload shims, 1/1000th of an inch more was enough to nearly double our spec and put us over the maximum threshold for the preload spec. So just to give you an idea, this is the thinnest feeler gauge I have. This is 1.5 thousandths. Look at how thin that is. It's extremely thin. So a thousandth of an, I mean, think of an inch divided by 1,000 times is how thin 1/1000th of an inch is. So it doesn't take much to get these things out of spec. Now that we've established our pinion bearing preload is proper, we can go ahead and remove the pinion one last time, put the seal in, and then reassemble it for final assembly. You can see there's some small particles of dirt and whatever from the shop table and pulling this thing in and out of the housing the last 8 or 10 times. So we're going to go ahead and blow this off with brake clean really well and air, same with the bearings, and we're going to get all that anti-seize off of the threads here, get this thing prepped to go back in the housing. Make sure you don't lose your shims. Sometimes the shims can get stuck like this to the upper pinion bearing. And we'll go ahead and do the same to the housing because you've been driving these races in and out, and every time you mess up those shims, there's a chance you get small pieces of metal like this in the housing. You don't want to leave those in there. Look at all that came out of there. I guarantee you that's all shim material because this front div didn't really have any big piece of metal like that in it before. The housing is nice and clean again, blown out real good. The bearings are beautiful and dry and clean again. We're going to go ahead and lube them back up with some more gear oil and start getting this thing assembled. Normally what I would do is I would go ahead and assemble this pinion in the housing. So I'd put the pinion in and I'd put the upper pinion bearing on because normally it doesn't slip on like this. So I don't want to be fighting this pinion falling out of the housing while I'm trying to put the seal in. I'm going to pack this thing with transmission assembly lube or grease. Something thicker is better, as if that spring pops out, you will not know it until it's too late. Get a light coating of grease where the actual seal is going to ride on here. Now we're going to take some Teflon paste and put it on the splines of the yoke to seal it so that it doesn't leak gear oil through the splines, because that will absolutely happen every time if you don't put silicone or something in here. On Dana's, they have this little shim that goes on top of the race here. I'm not an engineer, so I'm not entirely sure what it's for. It's not an oil slinger because it doesn't prevent oil from hitting the backside of the seal or anything. Some of these up here can be bigger. Some of them can even be smaller than this inner race. Best solution or best answer I've heard was like it keeps the yoke from fretting against the bearing. Now don't forget to put the bearing in because I have done that before. All right, that should be it. Red Loctite, that son of a gun. New washer and new nut. This should be it. Oh yeah, she's mint. And we are still within spec on our rotational drag. So this thing is done on the pinion portion of this job. And our final pinion depth ended up being 40 thousandths plus the 31 from this shim here. So you got a total of 71. And what we pulled it apart at was 75. But somebody had been in this housing before, front and rear on this truck. So there's a chance that somebody set this thing up wrong and had the wrong pinion depth shim in there. And so that's why whenever we measured the difference between the two bearings, we got such a drastic change on what should have been our pinion depth shim adjustment, but it ended up being damn near what we took out of it. Before we forget to do so, we're going to go ahead and install our inner axle seals on both sides of this housing. And then we get to move on to putting actual bearings on here instead of setup bearings. And that's a whole chore in and of itself, but since we've established our pinion depth is correct, all we have to do is set the preload on these carrier bearings, and then this axle is ready to be put back together. We've got a really long extension run all the way through the axle housing to this socket, and then I'll use this aluminum puck right here, and Paul will hit while I'll hold this kind of straight, and it'll drive that seal into the housing. Okay. We're back over at the comparator, and we took our setup bearings off of the carrier and are comparing them to our new carrier bearings. And we are only 2 thousandths smaller on our new bearings compared to the old ones. So we'll just compensate by adding shim. I went ahead and compared the measurement on my other setup bearing, and we're only 1,000th difference between this setup bearing and this one. And these are used bearings that I pulled off of an axle that I was re-gearing. So that's pretty good for used bearings to have a 1,000th tolerance difference. Now we need to select our shim stack for whenever we go to put our actual carrier bearings on that are the press fit style. I know for a fact that if we put those on right now without changing our shim stack at all, that these bearings are overall by themselves a total of 3/1000 of an inch thinner than what we had. So we're already going to be loose on our preload. And then, since this thing has a little bit of a chamfer at the bottom here, a little bit of a radius, these shims, even if these bearings were the exact same dimensions as the originals, whenever you press them on, it will squish these bearings further and it will fall into that housing with ease. So I'm going to start by just adding about 10/1000ths, so 5 on each side of the carrier, just as an educated guess to get us kind of started here. I decided to add 5 to this side and 6 to this side. Our backlash is 5/1000ths, which is the bottom of the spec. I liked that amount of preload. What do I do with the freaking... Oh, what do I do with it? Just gonna check our pattern one more time, make sure nothing has changed on us. Yeah, she looks good. Can you shut up? And we're done. Now we can put the cover back on and start putting shafts in. Dana doesn't give us with a total rotational torque with the carrier installed, but if you look up a 9 1/4 AAM front, which is virtually the same size housing, it also lists a very similar preload on the pinion bearings, and it says you should have 30 to 50 total rotational inch-pounds, and we are at 30, so our carrier preload is perfect. Got the cover all glued back on and need to connect this differential vent hose, but if we follow the differential vent hose, it just runs right up the control arm and it's hanging on the chassis right here. That's not good. It's full of dirt as is, and that is not where it's supposed to go. Man, I let Michael have the last 2 days of the week off. He didn't clean these up before he left. No more vacation for you. Don't worry about all that. We'll get it pressure washed up real good. But look at what we found when we wire wheeled this thing off. There's a big old dent here in the mating surface, a big old gouge here from somebody, I guess, driving a chisel down in behind the wheel hub assembly to get this thing apart. Whenever we take them apart, you put a socket between the axle shaft ears and you turn the wheel and it'll push this thing out. Got the hub assembly wire wheeled on the mating surfaces. Took the high spots down with a grinder on this knuckle so that the hub will sit flush. And then we put a light coating of anti-seize on this thing so that if somebody has serviced this thing in the future, it'll just pop right out of there. We'll also put anti-seize on the splines of the shaft so it doesn't get seized into the hub either. It's always something with these old trucks. This dust shield's broke, so I need to make it not broke. Oh, you suck again. It is not pretty, but got penetration all the way through. It's not very thick material, very dirty stuff, and I think it's galvanized too, so come at me, bro. I'm a mechanic first and a welder like 10th. These unit bearings on these second gen Dodges are held on with a 12.9/16 head bolt, and this truck only came in with 3 on this side, so we are missing 1 for the lower. We gotta come out here to the spare axle pile. We had to go get reinforcements because there are some spicy flying objects that are living in there. Not no more. Anyways, back to why we were out here. The Horde always provides. Gosh dang it, don't you hate it when it's too short? Guess the Horde didn't provide the right hardware today. That axle, I think, is a like 98 or 99. This is an 02, which in 02, it is a like 1 year only axle, so it doesn't have the CAD, and it's got the 3rd gen style ball joints and hubs and stuff like that. Well, I found a 12.9 Allen. It's the same thread pitch and the same length, so that'll have to do for free. Nobody's gonna know. It'll be our little secret. There are 2 different types of hub assemblies. One where the axle shaft torque does not matter, and one where it matters greatly to the life of the bearing. It's very simple to tell. If you've got this rolled edge on the backside and it is one solid piece from here all the way to the front, then that does not matter on the torque of the axle shaft nearly as much as the design here, where you can see this inner collar is where the splines ride, and your axle shaft actually rests up against this outer race for the hub bearing. So on this one, this is actually the shaft that goes in there. The shaft rides against that outer bearing race. If you over torque this nut here, it will actually preload the bearings too much and get them overheated and they can fail. On this one here, the axle shaft rides up against this flange, which is part of the spline section. So no matter how tight you get this, it cannot cause the bearings to be preloaded too much. You can see that that flange protrudes past that outer bearing race there. So as previous stated, these are the hubs that really matter on this torque spec. So we're going to jam a screwdriver in the rotor to keep it from turning. We're going to torque this to 175. That was 175 foot-pounds. You can see we're just shy of being lined up here. So I'm just going to take an impact and just impact this just a little bit more to where that cotter key lines up, because you don't want to back this off because it does hold the tension on the hub bearings. And it's my opinion that it should be just a smidge tighter than a smidge looser. New cotter pin and she's done. From the factory, these yokes on the front and rear axles use these little wimpy straps and these little baby bolts. And you put it on there and you tighten it down, and you cannot over tighten these. But what happens is the straps bend over time, and then the U-joint loses tension and it starts to walk side to side in the yoke. So we converted it to a U-bolt style yoke. It's my preferred yoke design, but you do have to be cautious because you can over torque these nuts and distort the cap and then cause the bearing to burn up. But Spicer does give you a torque spec for these U-bolts to keep you from doing that. So we have my snap-on torque wrench set up to use this offset torque adapter, and we are going to torque these. Spicer gives a spec of 14 to 17.
But if you round off what you got,
14. Now that we have the front pretty much buttoned up, we're ready to put the rear together. We've already pressed on our new rear carrier bearings, and this is all cleaned up. We did pull the pinion out with an air hammer, and you can see it took some serious air hammering to get this pinion out, so it would not surprise me if this lower race jumped up off the pinion, because that's super common when we're air hammering these out. So we need to press this lower bearing back on, and then we're going to put this back together with our original shim stack that came out of it with no pinion seal, and just make sure that our pinion bearing preload is correct. We don't want to assume that whoever put this together had it done correctly. We also don't want to assume that we didn't manage to lose a shim whenever Michael was taking this thing apart or something. And if I just put the seal in and throw all this stuff together and then find out that it's at 200 inch-pounds of rotational force, well, that's really going to suck for me because I got to buy another seal to get it all back apart. So we got our pinion cleaned up, and I have not repressed this lower bearing. And you can see that a 7/1000 inch feeler gauge fits into here, because whenever we air hammered this thing out, this bearing went that way on the pinion. So we need to press this back on before we put it in the housing. You can also see here there's a lot of damage to the threads. We didn't do that.
After an internal investigation, we found no wrongdoing.
Those threads on that nut are shot. So more than likely what happened here, because the threads are only messed up on the end, is it had messed up threads, and maybe Michael tore it apart and didn't realize that there was messed up threads from whatever damage at some point, and so as this nut came off, it screwed up the threads on the inside of the nut. Thankfully, the Horde had a spare Dana 80 pinion nut, so we are good to go. Just gotta fix those threads up. Google says that this is 1 1/4 by 12, and that is perfect. It isn't perfect, but if I can turn it by hand, it's good enough. This thing really should have used a replacement pinion, but I am like 99.9% certain that we didn't cause this damage because there are splines damaged pretty much the whole way down this. Alright, got the bearings lubed up, got our rusty preload spacers wire wheeled off, and got some oil on the bearings, and we're going to put this thing in the housing, put our yoke on, and torque it all down and see what our preload is on the bearings. Oh, that went on easy. Hold it. Alright, thank you. There's zero pinion bearing preload there, I assure you. Nothing. Absolutely zero. But there's no play. We're going to have to take probably 1/1000 out of there and hope that that isn't too much. Back apart we come. Had to bust out the micrometer to get these shims measured up. This one with the calipers measured about 19, and here you're seeing it's measuring 18 thousandths. So when we're only looking to remove 1/1000th of an inch, we need better accuracy. Finally got it. It's right at, like, if you watch the gauge, it's hovering around 10, 9, somewhere in there. So now we're ready to go ahead and put this pinion seal in, just like we did on the front. Since this thing just falls together, like that pinion bearing just slips on there, we're gonna go ahead and just put the pinion bearing in the housing, throw the seal in, and then we can final assemble this thing. Only use the best around here. Hold it in there. Check that out, 440 foot-pounds on that pinion. Now we are ready to put our carrier in and set the backlash on the rear differential. We are not going to check pattern. A, because we don't want to know, because it probably looks like trash, because it's had loose carrier bearings and the ring gear kind of cocked a little bit, but customer's decision to reuse it, his dice to roll on that. The way you can tell somebody's been in here prior to us is they have letters on here and here to index the caps, which is smart. I want to know how much side-to-side play. Oh, that's a lot. So this has worked relatively well for me in the past. Dana actually, I learned this today while reading their service information. This is how they recommend you do it. That's cool that I ended up coming up with the same idea that an axle manufacturer tells you to do. We're just going to count our side-to-side play. So that is 35 and 15, so 80 thousandths side-to-side movement. So, and since the shims were the exact same on both sides, and we have 80 thousandths of play side to side, I'm just going to start by sticking 40 thousandths here and 40 thousandths there. Might actually go 45 and 45, I don't know. We just got to get it closer than what we are now. So these are our new adjustable carrier bearing shims, and I call them a sandwich shim because you have an outer piece, an inner piece, and these don't change. These are standard throughout, and then you stack shims in between them, and it's got a little lip here that will keep these from falling out. And then now you can easily adjust your shim stack without the chance of driving in really thin shims by themselves and bending them. Because these are a constant, so we have 116 and 117 thickness already, we're going to subtract that from the 195 that was the factory shim, and then that'll let us know what our actual stack in between should be. So these super shim kits are actually made for a 10 1/4 Sterling axle that came in a Ford pickup, and whenever I was building Dana 80s, I got really tired of having to pull bearings off and adjust shim thicknesses. And then I had a set of these laying around. I was like, oh wow, they're the same diameter and they fit in the housing. And ever since then, I've been lucky enough that I was able to put it together with these. That being said, it's extremely tight. So if you remember, we had our 195 thousandths thickness original shim, and then we were going to add 40 to it because of the side-to-side play that we have. So we have 235 thousandths is what we roughly need on our total thickness. This super shim kit, the 117 and the 116 portion of the sandwich, which is a constant, it's always going to be there, is 233 thousandths. So we only have to add 3 thousandths per side. It's always super close. I decided just to shotgun a 6 and a 6 on our shims in between these sandwich shims and see what happens. Yukon sells these shim drivers, which fit the super shims really well. And this is a must for driving these into the housing, otherwise you'll mushroom the edge of them with a hammer. I will lightly drive it in, and it's kind of at an angle right now. All you have to do to straighten that out is get you a heel bar, stick in there on the race, pop it over, and now it's straight again. Oh, wow. Okay, all right. I was able to just push that in there by hand. So that's good and bad. We don't have enough preload, but we also have room to adjust our backlash. Not bad. Only 7 thousandths side to side. Pretty good for a first guess. I'm going to do something dumb here and pry it over this way. And I have nearly 0 backlash there. I pry it over this way. Oh, idiot. What are you doing? I blame Michael not being here. I'm going insane today. Okay. With it pushed all the way to the right, we've got pretty tight backlash at 3, and then all the way to the left, like 7. But this carrier can still kind of go like this inside those bearings, so that doesn't really mean a whole bunch to me. We're just going to pull our shims back out and add probably 5 per side. Well, the smallest shim that Yukon sends with those super shim kits is 6, so we'll add another 6 here and 6 there. If you remember how our shims were equal on both sides, I decided to go ahead and stick to that, and so I added another 7 and 7. So that would give us that's 14, it's close enough to 15 for our preload on the bearings. So hopefully this will be it. We're at the minimum spec of 4, but on a used gear set, the backlash will open up even if nothing else changes. Even, the bearings, if they hold their preload and everything, it'll probably lose 2 thousandths backlash over time. So I don't want to set this thing up on the tightest end of the spec, so it has the least chance of howling, Now getting this thing back out of here is going to be kind of a chore. I did actually order a case spreader today. I want to give it a try. It's totally acceptable to build differentials without a case spreader. Totally acceptable. And that's how I've been doing it for 10 years now. But I think that I might just use it for final preload assembly. So I'll set the differential in here and get all my pattern right, get my backlash right, and then I'll use it just for the final assembly. Literally every other video I've seen, people literally have them set up there for every adjustment. I'm like, I'm not doing that. You can put a wrench on the ring gear, and then it'll bind the gear assembly, and then you can turn the pinion and it'll force the carrier out. The one thing you want to be careful of, and I have done this before, is make sure that whichever way you're going, it's not loosening the bolt, because it will loosen the bolt. These are big enough bolts, there's no way at all possible that we're going to put too much torque on it, over tightening it. So we're just going to make sure that we're going the correct direction here, which is that way. Ta-da! I rearranged it to where I added 3 more thousandths shim to this side by taking 3 thousandths out of this side. Yeah, we're at 6 thousandths now. And spec was 4 to 10, so roughly in the middle. Our preload's perfect, our housing is clean, we're ready to glue the cover on and work on putting our hubs and shafts together. Well, I wasn't really gonna film anything on these universal joints, but I pulled this U-joint out, and it will be hard to tell because it's so dark in there, but there's a few needle rollers missing. I'm like, where'd those go? Come over here to the joint, and they're all in the center grease hole. That's not where those belong. I've installed a lot of U-joints in my day, and I've even screwed them up, but I have never seen somebody put the bearings inside the grease fitting. Because that would have to have been done, like, I don't know, before you stuff the joint in. I don't know. But that's not where those go. Don't that look nice? No more cheap universal joints for this truck. Don't forget to clean that differential vent. Got that factory one-ear clamp, son. This front differential hose should have been totally reusable because they didn't modify the length at all. Although I don't like the split in the end there, so I was probably going to replace it anyways. But there's a section here that's split, like really bad. So let's do some investigative work. So if we push this on here and run it up where it was before, that smash section is right under the bump stop. That's how it's supposed to be routed. It goes up and around the bump stop, up the side of the frame, clips onto this tab here, and then on the top side it'll get zip tied to the inner fender there. Now we get to bust out the old railroad track. So they cut it and then they machine this perfectly flat in a mill, and then now you've got an extremely hard surface to hit stuff on that's incredibly heavy so it doesn't move around. It's kind of like an anvil, but it's precision machined. If I were to try and pound the races in on this, this is a wood table and it bounces a lot. And I've even had metal tables with wheels and stuff on them before, and nothing works as good as this. This gives you a solid whack. Interesting find. Bosch. I guess they manufactured the hubs for these Dana axles. Woo! After we get done driving the races in, we're gonna go ahead and blow this thing out really good with brake clean. Clean all of our holes out here so that there's no oil in here from the parts washer. The races come with oil on them, and whenever you drive a metal race into a metal hub, there's always the chance that you get a small metal sliver in there. And I can literally already hear the people saying, why don't you freeze the race and heat up the hub? Sure, you could do that, but time is of the essence, and that is time consuming, and driving them in with a hammer is literally what the factory service information says to do. So come at me, bro. You just want to visually inspect the hub, make sure that the bearing race is seated all the way around. There's no debris inside of it, and she is ready to go. Whenever tightening these hub bearings, a lot of people don't realize that these do not really need to be tightened all that tight. You tighten it to like 120 foot-pounds, back it off, and then just barely, like finger tight. It's supposed to have 1/1000th of an inch of in play up to 10/1000 of an inch. And then the thing I really like about these is these nylon nuts. They're reusable to some degree, but you get this little keeper and you put it in here and you just hammer it in, and that's what keeps that nut from backing off. Versus most of your other designs, with the exception of the Ford ratcheting style, require you to pick a setting that's either a little too loose or like a lot too loose or too tight. And so I really like this because it damn near has infinite adjustability. I had Michael fill up this rear differential completely, and we still have the axle shafts out. And guess what you don't see? Any gear oil coming out the sides. You can kind of see that it's in the tubes there, but it's nowhere near coming up high enough to make its way out the spindle area into the hub bearings. That's why it's so important once you get done doing hub bearings, even though the differential is completely full, that you tilt the axle to get oil out to these hubs. Otherwise, you will have a very bad day. Work it. So it'll probably be kind of hard to tell, but there is no differential noise from the rear differential at any highway speed. This truck does have mud tires on it, so it's a touch loud inside the cab, but overall, good to go. Well, this is not where I wanted to be after a test drive, but I drove this truck for like 50 miles, and then I really wanted to check these hub seals because I was not comfortable with the grooves in the spindles. The spindles have a groove here where that seal rides, and you can't offset the seal outward more because there is a probably a 20 thousandths inch deep groove, like a chamfer at the edge of the hub. And so if you offset that, you're really only going to get maybe 1/8 of an inch of sealing on the outside of this seal. Not the inside where the sleeve is right now, but on the outside. So I don't like offsetting them there. So you can press them down into the hub more. But this spindle, it'll be hard to see, but it's got a nice little groove there where somebody, I don't know, somehow hit something there that way. And so that seal is not gonna ever seal there because that groove is deep. So you could, you know, try and JB weld it and sand it down. Some people will chuck these housings in a lathe and weld this groove up and then turn it back down. I don't have a lathe that large. We are going to try the speedy sleeve repair. So this is the part number that everybody claims to have used with success online. The drag on this seal, you know, it seems excessive, but I'm just going to go with the fact that everybody's had good luck with this. I have attempted this one time in the past, about 10 years ago on my personal truck, and had absolutely atrocious results. So I've learned a lot since then, so we're going to try again. And the way that I was actually able to see this hub seal was leaking was with a bore scope through the backside of this brake adjuster port for the parking brake. The other side looks perfect because I was able to offset the seal inwards and it didn't have that little nick where somebody screwed it up. The video I saw online, some dude had a genius idea because these speedy sleeves, this is what it looks like. It goes onto the spindle like so, and the installer doesn't fit. Alright guys, first time doing this as a professional, so I didn't really want to record it on the off chance it didn't go well. Didn't want to have to be about recording. But we stuck the sleeve in the back side of the hub, and then we put the hub with the bearings on there, and then we just lightly tapped it to get it started, and then we used the hub nut to just pull it on as an assembly nice and straight because the bearings keep this hub square. And then we got it to a point, and then you had to get in here with a chisel and knock off this inner, you know, driver piece. And yeah, that was it. As for right now, the tension on the seal is definitely more than it would be stock, but you know, that what do you expect whenever you're increasing the diameter of the area where that seal is riding. So wish me luck. Here we're looking in the back side of that hub assembly we just did the seal on, and it is dry as a bone, which is good. We did put this on about a 50-mile test drive, so that's a good result. I'm comfortable letting this thing go now. After 100 miles, our pinion seals are still looking nice. Rear is dry too, so we're good to go. Another one down. On to the next.